Okay, everyone. Today I will go through the lesson. There's chapter 5. There's radioactive. I think this one topic there's not related with the before topic. There's form 5, the last topic. There's own topic. They're using the physical quantities and also all the formula. There's a difference with the original, the before that what we learned. So from here, this one notes I already upload in the Google Classroom. For the student, you are not yet photostat, that means you can download from there. Okay, so we start our lesson. There's a 5.1. There's a nucleus of an atom. Okay, let's see the notes here. Okay, first one, we need to talking about the Rutherford module. Okay, I think this one you are more clear about, there's a talking about the chemistry lah, a little bit related with the chemistry. So Rutherford module, so from here they say the atom has a positively charged. Okay, they got positive charge. Or they say a nucleus, okay, which contain the most of the mass from the atom. The whole atom, that means center. Okay, center that contain with the proton, there's a positive charge, and also the neutron. So from here, the whole atom, the most of the mass of the atom is from the center. So the other surrounded, there's an electron. So this one is what the Rutherford model they're talking about that. Okay, let's see the diagram here. Okay, the negative charge that's orbit around the nucleus. Okay, center, they got very small positive nucleus at the center. Okay, now we're going to see Geiger-Madison. They plan to carry out the experiment to find the evidence for the Rutherford model. Okay, let's see the Rutherford model. Earlier, they show the model they're talking about what? Okay, this one is a diagram for the Rutherford nuclear model of the atom. You see here, the nucleus is a very small, dense, and also positively charged. Electrons surround the nucleus. Most of the atom is empty space. So that means surrounded beside the nucleus, the surrounded with the nucleus, there's an empty space. Okay, that means the nucleus is very small. They put at the center. Then the other way is an empty space. This one is what Rutherford to say. So from here, we need to prove, is it the Rutherford talking the thing is correct or not? So from here, we're going to see how they're using the experiment go to prove it. Okay, now you see the first one. They fire a stream of the alpha particles. Okay, one more thing to tell you, alpha particle, there's a positive particle. Okay, there's a positive particle. The very thin go to where? Go to very thin gold foil. This one we call thin gold foil. And counted how many alpha particles were scattered at the number of the different angle. So this all is an atom arrangement here. Now let the alpha particle to pass. Okay, when the alpha particle to pass, now we need to see the result. What's the result? You see it. Okay, we see here. First one. Okay, most of the alpha, they pass straight to. So that means many alpha, they go straight line. Okay, the next one, we find it. A few of the alpha, they are deflected from the large angle. So that means when they just come here, they will deflected. Okay, last one is a few of the number, alpha also, pounced back. So this one is a 3 situation. We get it. Okay, now we're going to see the biggest diagram. I show you the biggest diagram. Okay, this one. Okay, you see this part? Okay, this one is an alpha particle that scattered from the gold foil. Okay, can you see some is punches back, but many of the alpha is go straight. Okay, go straight. Then a few they will punch with a small angle. Then also with some very small part they will punch back. So that one we call it as a experiment from the gold foil. Okay, now we need to conclusion. This whole thing actually is what meaning. Okay, let's see your notes. Here is a result. Okay, first one they say most of the alpha pass straight. What's the meaning for most of the alpha will pass straight? The meaning is the space inside the atom, we can say that completely there's empty. So that's why the thing is like this. when your nucleus very small, when the alpha they go. So that's why many can go straight. What's the reason? Because you are empty space. So that's why many can go straight. Okay, because of this one result, many can go straight, so we can conclude the whole atom inside the nucleus sure is a very small size. Then surrounded with the empty space. Then one more thing, the nucleus must at the center of the atom, because we find it all the alpha parts is at the side. Okay, so this one is the first result. The second result is a few of the alpha particle deflected. Okay, that means they got deflected with the small angle. Deflected means the nucleus and the alpha are positively charged, so that's why they will deflected. Remember, positive and positive, they will repel. So that means this one is your atom. Okay, many is go straight, is it? But some alpha, when they just closer with the nucleus, so they got punched. Okay, why got punched? Because they got repulsive force. How come got repulsive force? Sure, two of the charge become the same. So that's why they got repulsive force. So from here they say they repel each other because repulsion force produced between the light electric charge. Both is the same charge. So that's why they will repel. Okay, so that means this one, the result is alpha closer with the nucleus. Then what we prove? We prove inside the nucleus got positive charge. That's why they will repel. Okay, the last one. Very small number. Alpha pouches back. Pouches back means totally come back. Okay, so totally come back means what? Means the repulsive force is very strong. How come the repulsive become very strong? When you are very close with the nucleus. So that's why they will repel straight, come back. So from here the explanation, when the alpha particle approach very close to the nucleus, so after that they exert by the very large repulsive force. So that's why they will come back. So from here, what conclusion we get it from this one experiment? We find it inside the atom, we got one small nucleus. Then at the center. Then inside the atom, we got so many empty space. Second one, inside the nucleus, they got positive charge. Okay, so that means when the alpha just closer with the positive charge, we find it we got big repulsive force. So that's all. This one is a conclusion from this one experiment. So that means this whole experiment totally never prove about electron. Just talking about the proton inside the nucleus. Okay, so this one is they want to prove the Rutherford using the dingo foil experiment to prove it. Okay, now we're going to see the first one. What we need to know today is the model of the atom. So what we learned today, the model of the atom, center, they got one of the nucleus. Okay, inside the nucleus we got neutron. Then we got proton. Then surrounded the orbit we got electron. So this one is what we learned today, the model of the atom. So from here we need to find it, proton, neutron, and also electron. Okay, this one, proton and neutron, when they mix together inside the nucleus, we call it nucleon. Okay, nucleon number, nucleon. So from here we need to see one by one, proton, electron, and also neutron, what is the properties. Everyone, what is the properties? Okay, let's see here. Okay, first one we see about the charge. Proton sure is a positive charge. Electron is a negative. Neutron is neutral, no charge. Inside the charge will be neutral already. Okay, let's see the charge value. 1.6 times 10 power of negative 19. So this one is put negative. If the electron, then the neutron is no charge. Okay, let's see the mass. Okay, mass for the proton, mass for the neutron should be the same. Then you see the electron. Electron is a negative 31. Negative 31, that means we can ignore the mass already because that is too small. So total, finally, we want to measure the mass for the atom. Actually, we measure the proton and also neutron. Actually, the electron we ignore already. They cannot support any mass for the atom. Then the last one is a symbol. Okay, proton. This one is nucleon number is 1, proton number is 1. Then electron, we don't have any proton number, so we put 0. Then negative 1 is a proton number for the electron, that's a negative 1. Okay, neutron number, they got 1, no proton number, so this one neutron, they got 1 nucleon number, then 0 proton number. So this one is a properties for the 3 of the alpha. We can say proton, electron, and also neutron. Okay, the next one, we go and see the proton number and neutron number. Okay, let's see the proton number and neutron number. Center, this part, we call it there's X, there's one of the element. Okay, symbol of the atom, sometimes using carbon, nitrogen, or sulfur. Okay, so from here, this one they show you. Okay, at the top, this one is a mass number. Mass number, we can call it as a nucleon number. Nucleon number actually is a mix with the proton and neutron. Okay, the down one we label there's a atomic number, or you say there's a charge number. Okay, atomic number means a proton number lah. That means we just count about the number of the proton and also number of the electron. Okay, so I think this one you are more clear than me because you learn about the chemistry. Okay, now we continue with this part. Okay, the number of the proton plus the neutron in the nucleus, we label with the A. Okay, at the top. Okay, Z is a proton number. So that means if you want to find the neutron inside this atom got how many? So we need to do the calculation is A minus Z. So that means the A number must be more than the Z, because the A is neutron plus proton. Okay, the Z just got proton only. Okay, for example, let's see this one, example 1. Okay, this one is sodium, is it? Okay, 23 and 11. 23 actually is what? 23 actually there's a nucleon number. There's a A. Okay, this one is a Z. Z is a proton number. So the proton number we got 11 only lah. So the nucleon number 23. Neutron number, there's a 23 minus a 11. So you get 12 for neutron. So this one is normal, the simple thing for the introduction for nucleus. Okay, then the next one should be the isotope. So the isotope, we need to know the definition. The first one, isotope are atom of the same element with the same proton number. Same element means if I using carbon, so another one also carbon, the element should be same. Then they say proton number become the same. So the bottom one, Z and Z must be the same. Proton number same. Different nucleon number. So here maybe is A. This one is an actual one. This one A plus 1. So this one is another type. So this one we call it as an isotope. Same element, same proton number, but nucleon number different. Nucleon number different means your neutron got extra. Okay, neutron got extra. So finally your neutron number become different, but all the elements become the same. So this called with isotope. Let's see the example for isotope. Okay, this one is one of the isotope for carbon. Okay, this one is the original. Nucleon number is a 12. Proton number is a 6. Okay, we see another isotope. There's a 13. So you can see the nucleon number extra already. Okay, proton number still the same. So this kind we call it as a isotope. Okay, now we go to the second page. Okay, let's see the second page. Okay, second page they explain about the isotope. We go to explain isotope actually what is that. Okay, isotope have the same chemical properties. Okay, when you do any experiment, I don't care your carbon is 12 or carbon is 13, your result should be the same. So this one we call chemical properties. Okay, because why they got same properties for the chemical become the same? Because they got number proton become the same. Okay, when your proton number and electron number become the same, chemical properties must be the equal. Okay, how about the physical? Okay, different physical property. Physical properties means the thing we can see, like example, is a mass. Okay, the mass, when the proton number same, but the neutron is a different, so you find out the mass become different. So this one we call it physical properties. So from here, isotope, physical property is a different. Okay, then the chemical one should be the same. So this one is an isotope definition. Then we see example is a hydrogen element. We got 3 nuclei for the hydrogen isotope. First one we call hydrogen, the normal one. Okay, the next one, now you see the nucleon number become 2. This one we call deuterium. Okay, deuterium. Okay, third one is a tritium. The tritium we got 3 of the nucleon number. So this one is an example for the isotope. So this one is a stable. Okay, the unstable one, normally we call it as an isotope because you got extra. Okay, let's see the example for the isotope here. Okay, this one same as your the notes for the hydrogen. Okay, so can you see deuterium, tritium? Okay, so this one is a hydrogen isotope. Then we go through to the following. Okay, so the following we start with the tutorial already. So let's see the tutorial. Okay, let's see the first one. Okay, the result for the Geiger-Madsen, there's a scattering experiment. This one present of the nucleus within the atom. Okay, what was scattered in this experiment? So from here we just using what? Okay, we never using any negative, is it? We just using the alpha. So the answer should be A lah. Okay, number 2. Number 2, the narrow beam alpha particle, they fire thin piece of the gold foil. Some of the particles get just large anchor. Okay, after that, the result of the experiment provided evidence of the existence of, okay, why got large anchor? Why they will bending? Okay, important is inside the nucleus we got positive charge. Okay, number 3, the diagram show the beam of the alpha particle in the fire thin piece of the gold foil. What is the final direction of the most alpha? Most of the alpha, where to go? Okay, we can see most of the alpha. Okay, question asks most. Most will go straight, is it? So your answer goes straight. Where's the straight? There's a A. Okay, then we continue with number 4. Okay, they got nucleus surrounded by the particle. Which one following it gives the structure? Inside the nucleus actually got what? We got proton and neutron, is it? Surrounded by the electron. Okay, number 5. Which of following is a characteristic for the neutron? Negative charge, no. Orbiting the nucleus, no. Having, okay, same mass, okay, there's no charge. Having the mass become same as the neutron. Okay, number 6. Nucleon number of an atom is the number of, okay, nucleon actually is what? There's a proton and neutron. So the answer is donkey. Okay, 7. Lithium, 3 electron, 3 proton, and 4 neutron. So from here we put lithium. Okay, you got 3 proton number, 4 neutrons. So what is the nuclear number? 7. So the answer, donkey. Okay, we see number 8. Okay, natural atom. Natural atom means the proton number and the electron must be the same. This one we call natural atom. Okay, we go and find it. Okay, this one is 16, proton number. This one is electron, also 16. So this one become the natural. Okay, the answer is C. Then we go number 9. What means of isotope? Isotope for the must be same element with the different number of neutron. So the answer is donkey. Okay, so this one is a 9 objective question. Then we continue. To the last page. Okay, number 3 first. Okay, let's see the number 3 for 10. Okay, which of the following of the isotope is true? So we find out which one is isotope first. Okay, proton number become the same. So we go to check. Where's the proton number become the same? So 4 and 4, 3. Okay, this one out. So this one out. Excuse me. So this one out. So the answer should be C lah. You just find the proton number. Okay, 11 got deuterium and tritium. They got 2 isotope hydrogen. Compare the deuterium atom. How many proton, neutron, and electron? Okay, proton and electron should be the same. Just the neutron be called extra. So from here, same, then more. So the answer is C. Okay, then we see question 12. A new model of the atom has suggested by Rutherford, Madison. They fire alpha particles. At the thin metal foil, alpha particles are positively charged. So in their model, that each of the atom has a nucleus. Now the diagram they show one of the path of the alpha particle. When they pass through the nucleus, okay, they got band. This one we call a field that band with anchor. Okay, band with anchor. So from here, they ask you to explain why the alpha particle changes direction. So for this one situation, you must talking the alpha when it just close with the nucleus of the atom, then they will bend because they got repulsive force. Why got repulsive force? Because inside the nucleus we got proton, that's a positively charged. So the like charge, they will repel to each other. Okay, so this one is the explanation. Then I can show you the explanation here. You also can refer your notes. What is the explanation? Okay, let's see here the explanation. Okay, because the nucleus of the atom and the alpha particle are positively charged. That means nucleus is a positive, alpha also positive. So therefore, both they will repel to each other by repulsive force. So you must talking about repulsive force. You also must talking both is a positively charged. Okay, so this one is the answer for question 12.1. Okay, then we continue for the next. Okay, let's see the next one. Okay, the diagram that show the different path taken by the alpha particle when they will fire Rutherford and Marsden the thin metal foil. Now we go and see the first one. They got go straight, there's a X. Then some is anchor, there's a Y. Okay, Z is pouches back. So we got 3 situation. So from here you need to draw the line. The boxes that left some of the observation from the experiment. So the box of the right give the explanation, draw the straight line. Okay, for the each one observation. Okay, let's see the first one. Most of the alpha particle follow path X. So the explanation is what? Because most of each atom is empty space. Okay, so this one already answer for you. Okay, now we continue with the next one. Okay, because we see the explanation, because the nucleus has the very large positive charge and large mass. So from here, which one should be the answer? Very large positive charge. Okay, if very large positive charge, that means there will pouches back, is it? Okay, so from here we can choose which one is a pouches back. Some alpha particle repel backwards along the path Z. So this one should be the answer. Okay, number 2, because the nucleus is very small. The nucleus is very small because it goes straight line. So we find it the nucleus become very small, is it? So we're going to choose some of alpha particle travel along the path Y. No, path Y deflected. Very few alpha particle follow the path. Okay, some they follow the path, mean go straight. So from here we prove it. There's a very small nucleus at the center. Okay, last one. Because the nucleus is positive charge. Okay, they just say nucleus is a positive charge. So a few, they will never punch back, just bend angle only. So this one become the result for your drawing. Okay, you can check from here. Okay, this one is the answer. Okay, you just draw the line to show the explanation. Okay, then we continue with the next one. Okay, question 13. The diagram present the three atoms. There's a X, Y, and Z. Okay, we're going to see this one symbol. The dot means there's a proton. Cross means electron. Okay, if the element become the same, that means the proton and electron must be the same. Okay, so from where you're going to check which one proton number is the same. 7, 6. Okay, 6 and 6 proton number become the same. Electron also become the same, just the neutron is a different. Okay, so from here we can conclude lah, Y and Z actually there's an isotope, because proton number is the same, just the nucleon number different. Okay, then we go to last page. Okay, last page, the first one they ask you which of the atom are form the same element. So same elements means the proton number become the same, neutron number, the electron number also is the same, so there's the same element. So from here we find it, there's a, okay, refer just now the diagram. The Y and Z become the same element. Proton number, electron number is the same. So there's an atom Y and also Z. Give the reason why they say there's a same element. Okay, so we give the reason why become same element. Both atoms have same proton number proton number, you can say proton number, but normally we never mention about electron. We're talking about the proton number. Both have the same proton number. Okay, then after that, and both also isotope. Okay, that's the same element. Okay, and also the proton number is the same, so that's why we call it as isotopes. Okay, last, in the part of the 20th century of the scientists investigate the odds taken by the positive charge alpha particle into and out of the thin piece of the gold foil. So now the diagram they show about the path of the 3 alpha. Okay, let's see the path. First one is A, go straight. Okay, B got bending a little bit with the angle, so we call bend with small angle. Okay, and the last one, can you see they pouches back? So this one pouches back, so later you need to explain why they will go back. Okay, now you need to explain the different path A, B, C for the alpha particle. So A, 1, what's the explanation? B also same, C also same. So everyone you need to explain. So you can refer the in front, they got the notes to explain A, B, C actually is what's the result. Okay, here also we can show you the answer. You can do first, later you go and check the answer here. So final answer, I go to explain a while. Alpha particle, they fill with the empty space. So that's why the most of the alpha will go straight, follow the path A. Okay, alpha particle and nucleus atom are positive charge. Okay, so there are small repulsive force of them at the path B. Okay, center is a positive charge, When you just close, they will bend a small angle. So now I can prove they got small repulsive force when I just close it. Okay, number 4, they got big repulsive force produced by the path C when the alpha are close with the nucleus. Okay, 4 is a big repulsive force. The second one, you just say inside is a positive, then you produce small repulsive force. So this one is a final answer for A, B, and also the C. Okay, so this one is our lesson for the chapter 5.1. So now everybody, okay, just thank you for your watching. This one is a 5.1, then the coming soon should be the 5.2 lah. 5.2 I also already upload. Make sure you read before, okay, when I want to explain this one topic. So I think that's easier for you all lah. Just follow only. Then with the calculation also less. Just some concept you need to explain. Okay, thank you everyone for your watching.